Hi, in the last video I showed you how to use radare2 with operation command to actually modify the binary in place. But the example I used was just a made up with a few bytes in it. This time I will show you how to use this functionality with a more real life example. What I will use will be one of the last mission from Ginville channel. The actual mission was on the Polish channel, but that doesn't matter. What is known is that the binary uses self-modifying code. So actually this would be a perfect example for write with operation commands in radare2. The link to the mission is here, and also to the files are in the description. So I just download the files, and I will now show you how to use radare2 write with operation to actually solve this challenge. Okay, so I have the files downloaded in the folder, so now I'll just run the file in radare2 and just move to the binary. The code is not very difficult. It's just uses the self-modifying code. So if we just navigate to the main function, we'll see that the binary asks for the password in the argument, then checks its length, and displays okay or not okay. And what's interesting is this object code that it's being used, and we see calls to mprotect and also a call to racks, and probably in the racks there is an address of this code in memory that will be executed. So let's just move there. Okay, and here we see the self-modifying code. The first part is readable, but the further we go, we see some strange characters, or opcodes, actually. And we see that the first part is actually a loop that will XOR the bytes from 20, 10, 39, which is from here, to 64. So it will XOR the bytes, and it will do that to get the actual opcodes that are here, that are currently gibberish. So let's do that. So let's decode those bytes in radare2 using write with operation. So first what we need to do is actually to open this binary in read-write mode, which is done with OO+, because otherwise we can't, the write will not write anything. Okay, the second thing, we need to actually calculate how many bytes we need to XOR. So let's do that. Well, let's just copy the bytes from here to here and just calculate how many of them we need. Okay, it looks like 2B. Okay, so 2B, and the operation is XOR with OX55. So if you remember correctly, WOX is write with operation, and the operation is XOR. Now we need to put the key, then we need an ampersand, we need an address. So again, let's just copy it. And the last part is that the length, and it has to be in decimal. So and I forgot of course to be, how many bytes is that? It's 43. Maybe it doesn't have to be decimal, but let's try to be. Maybe not. Okay, and it didn't work. No, it did work. There's some strange coding here, so maybe let's just remove those flags. strpx okay, it looks much better. So maybe the next one and the last one. be just remove all. Okay, so now we see that the rest is more readable, and we see that there's still something that gets modified. Here we see that at address 20104D we add to the byte we add 61, and if you look closely, this byte is this one. So basically this is one more trick to actually make sure that you will not analyze this binary correctly. So we can also do that in radare2. So again, write operation, and this time will be add. We will add 61. We need an address. And this time it will be 1. Okay, so now this changed. So instead of 66, it's now C7. And this is important because if you would analyze this binary without this modification, you will of course get the wrong result. Okay, so now the binary is the code of the binary is as it should be. And if you analyze closely, this part is just the loop that checks if the code you enter is correct. And if you would analyze a bit more, the RDI is the register that the flag that was passed to the binary is given. So and the main part is those three XORs. And to make the application exit correctly, we need errorx to be 1. And this can be done if at the end of this loop ASI will be 0. And how we can do that? It checks the bytes from this address 20106F, which is here, and it XORs with this value and with our flag. So how to make sure at the end of this process we will get 0? Well, basically it's very easy. If we give the same values as are given here with after XORing with OC7, we'll get 0 at the end, because XOR will zero out if you XOR with the same value. So let's see what actually is written here, and after XORing with C7. So again, we can use WOX. Now the value is C7. The address is this, and the length. And I didn't say about it, but it was the length was checked in the main, and it was 13 hexadecimal, so it will be 19 characters. So let's do like this, and if we do that, we see that something is changed here. It's no longer code that is actually readable, but it looks like it is right now an ASCII characters. So let's convert it to string. And the flag is here. So flag self well done and exclamation mark is something that we need to give to the binary, and it will it should write us the well done as was seen in the main function. Okay, so let's try that. Maybe copy this one. Okay, let's quit radare2 and SMC. Yep, the one thing we need to do, of course, is to escape the exclamation mark character. It will be interpreted. So if we do like that, we should get well done, and we get the flag self well done. Coredown, of course. The problem here is that, of course, I modified the binary and I don't have the copy of the binary. So when the binary tries to modify itself, of course, it gets the wrong values. So let's do one more thing. Let's download it again. Okay, now we have the new binary, and if we run the new one, flag self, well done. Well done. Okay, so in this video, I showed you how to use write with operation in radare2 to actually use still static analysis to analyze the binary, but of course with some small modification to the binary that basically gives a bit better overview what's going on. Yeah, and I hope it's useful. If you have any questions, write them in the comments. Thanks again for watching. Bye.